Okay, so this technical session will be about the access tokens. In order for all these calls to work, you have to watch all the previous sessions because that's all the preliminary work needed to get the access tokens to work and have all the OAuth flows do what they are supposed to do. Quick agenda. I'll cover the service-to-service flow. This is a specific OAuth flow we designed. It's in our RFC 21. I'll discuss the OAuth scope to presentation definition mapping. And I'll discuss the OpenID for VP flow and the access token introspection. Finally. Okay, so we'll start with the service-to-service flow. Because OpenID for VP is designed to get access tokens to authorize for with users in mind, we're left with a problem because in data exchange there's also room for specific server-to-server communication. For example, if no patient data or user data is involved, there are a lot of calls you can do. So this is a hole in the entire worldwide specification if you're using verifiable credentials. So we defined our own flow. It's usable for server-to-server communication. If you're going to use this service-to-service flow or the regular OpenID for VP flow, that's your choice as Axis ACD vendor. If you call the APIs at the NTS node, it's your choice to initiate a service-to-service flow or the user-based flow via OpenID for VP. What it uses is the organization wallet. So the NTS node is an organization wallet. It can hold verifiable credentials for the entire organization. This is a construct that is required in the entire world. So if you talk to other domains, they also say, okay, we need a organization wallet. But currently, all these new protocols and implementations are still focusing on the user. So the service-to-service flow uses the organization wallet, which also requires you to upload credentials via an API. So these are the specific calls you have to do and the answers you're getting back. The service-to-service call is inspired by the, I think, RFC 7523, the JWT bearer token call. So it's a single request response where actually two requests and two responses where verifiable credentials are used. So you as a caller can create a verifiable presentation, which is posted to an endpoint and you get an access token in return. This is all done by the NTS node. So if you do the top API call to an internal endpoint with the given data, so you have to select the verifier. Where are you requesting the access token, the scope, and the token type. So basically, your choice would be, or what you have to do is, for your use case, which we covered in a different video, is find the DID where you need an access token. This is also done within a certain scope, certain use case, and then use that information to call the API on your NTS node. I'll talk about the token type in the next slide. If everything is all right, so if the organization, your customer or your tenant has the correct verifiable credentials in their wallet, and you satisfy all the requirements from the verifier, you will get an access token back directly from your API call. And this access token can be used like any other access token as a header, as a bearer token. I think this is not a very complicated mechanism. Okay, so this is the point where I'm going to explain the proof of possession RFC we added. It's quite a new standard for OAuth. As in the previous slide, you saw that the token type was set to bearer. As a client, you also have the option to use a depop token. This RFC, which the final version was created just at the end of last year, prevents token hijacking. So that's especially for this service-to-service flow, it's quite an important security improvement. The downside is that you have to generate a new proof, which is cryptographically signed for each request you do. And also at the other side, after you do token introspection, the resource server also has to validate each request. And the resource server is responsible for this verification. Okay, so how does it work? So if we look at the request access token, instead of requesting a bearer token, we request a depop as token type. And for the service-to-service flow, you just get an access token, as with the bearer token type, only it says token type depop. If you do this with any other kind of OAuth server that supports depop, good luck in finding them. The authorization server could or could not issue a depop token. It could also still be a bearer token. So we have to look at the return token type to actually use it as a depop token, because it can also still be a bearer. The nuts node just gives you a depop token type if you request one. So this is the same as before. So you just request a token from an internal endpoint and you get a access token in return with a different token type. What you have to do next, and we created some APIs on the nuts node for that, is you have to generate a depop proof for each request you do. So we created an internal API where you send the HTTP method and the HTTP URL together with your access token. And that information is then cryptographically signed into a depop proof, which is returned in the second black box. You have to add this depop proof to the depop header, as you can see in the last black box. This is an additional security measure to prevent access token hijacking. So this is creating and passing the depop proof. At the other end, you will get the depop proof in a header. If you do token introspection at the nuts node, so you get the access token, you do token introspection at the nuts node, you will get a thumbprint back for the public key used in getting the access token. So with the information you got from the token introspection and with the depop header, you can call a convenience API on the nuts node, which is in the top, where you send all the information needed. So that's the depop proof taken from the header. You send the access token, you send the HTTP method, and you send the URL requested, and the thumbprint taken from the token introspection. And then the nuts node will validate this depop proof. You will get a valid true or false in return, and if it's false, you also get the reason why it's valid or not. So what the Nets node does is it checks if you're using the correct, if the correct public-private key pair is used, if the signature is correct on the depot proof, if it belongs to the access token, if the method and URL are valid, and also if this token has been used before. So it also protects against replay attacks. So that's it for the depot proofs. Currently, using depot proofs is optional. So if it is to be required, it has to be defined per use case that you want to use it. Okay. Next, we're going to the scope representation definition mapping. We covered something like this before in the discovery service presentation. And this is, well, sort of the same, but it's used in the OAuth flow. It will be required to specify one or more scope to presentation definition mappings per use case. And these can be stored in a directory as a YAML file or JSON file, no, it's a JSON file, which can be configured by your policy directory configuration parameter. These files will be extremely closely related to the discovery service configuration files. I think the discovery service configuration files, the presentation definitions there will always be a subset of the configuration files used for the OAuth flow. For the organization credentials could even be just the same, but a user mapping could be added. So for example, if you have a use case where the presentation definition for the discovery service says you must have an organization credential and you must have a qualification credential for that use case, then probably the presentation definition for the OAuth flow will say, for the organization wallet, you must have this organization credential, you must have the qualification credential, but it will also add, and there must be a user, for example, with a valid UZI credential. So that's the way those two are closely related to each other. Right now, they're still separate configuration files. So this is an example of one of those JSON files. At the root level, you see here there's test. This is basically the scope you pass when doing the authorization request. So those are the scopes used. And one level deeper, we currently support two identifiers. One is organization and the other one is user. So organization defines which credentials or which credential requirements are required for the organization wallet. And the user part defines which credential requirements are for the user wallet. So at the top, there will probably be something like an organization credential, which also defines, I want an organization identifier, I want the specific issuers. And for the user, you'll probably have something like, oh, I want a UZI credential, or I want a credential issued by the Dutch government, telling me the name of this user, and I want a specific issuer for trust reasons. So that's the mapping files. And now we're going to the OpenID for VP flow. So this flow implements the entire OpenID for VP, well, not entire, required parts of the OpenID for VP specification, I believe draft number 20. And what we implemented. So if you look at the recommended OAuth security measures. And also, if you look at the recommended security measures for OpenID for VP, we implemented quite a list. So our entire flow consists of one, what we call an outer OAuth 2 authorization flow. So this is a normal OAuth 2 authorization request. And there can be multiple inner flows because you request access, and as a response to that, the verifier, or actually the authorization server that will act as a verifier, will do OpenID for VP requests back to your wallet, to your holder. And it will do one for the organization, and when that's done, it can do another one for the user. So it can do multiple authorization requests. What we implemented is JSON Web Token secured authorization requests. So authorization requests are signed. We use what is called PKCE, which is Proof Key for Code Exchange. This means that the authorization request is linked to the access token request, and it is needed for public clients. Because what we do is we do not use registered clients. So there's no client ID, client secret required because, well, we're using DIDs, so all key material is available. So we use public clients. And that's why you need something like PKCE to get the authorization call connected to the access token call. And optionally, we can use DPoP, demonstrating proof of possession. So you're protected against token hijacking or request replace and that kind of stuff. Okay. To start a flow, there's an API for that. As you can see, if you look closely to the top API call, it's called request user access token. At the beginning of this presentation, we had the service to service flow, and that one uses request service access token. So that's where the different choice lies for getting a service to service service access token and a user bound access token. So if you want in a use case to have a higher level of security because it's medical data, and you also want to comply with auditing requirements, and you want a user to be present, you have to use this API call. What is important for this call, and what is different from this call, from the service call, is you have to pass a redirect URI, which is common with authorization requests. And you can also, well, currently you have to pass information about the user. This is because currently there's no compatible wallet that can deliver user-bound credentials. Even if you look to the OpenID for VP standard, if you want, for example, connect the Microsoft wallet, well, then you have to use draft 15, I suppose, and we're currently on draft 20, so something will break. But we're working on that. Hopefully in a few months, all those specifications will get a new implemented draft, and then different wallets will align with the stuff we implemented as well. And then you can also use, hopefully use mobile wallets. But for now, what you can do is you can add a pre-authorized user to this call, which is basically the user information from your user from the XIS or ACD. And this information will be passed and will also be visible in the token introspection, so you can comply with auditing requirements. Right now, you can pass three things: its name, its identifier, and its role. This is all self-claimed, so self-attested. So there's no validation if this data is correct. The response of this API call will be a session identifier, which you can use to get the access token later on, or you can use it to pull the current status of your request, and a redirect URI, which you have to pass to the web browser, so the user can be redirected to different points. The session ID will be used to retrieve the access token. It can also be used to pull the current status of the process. So for example, there's different options where you can redirect the user. You can, of course, use the main page and redirect control to that redirect URI, but you also can use iframes or pop-ups or a mix of those. So if you want your main page to pull for the current status and update maybe in a pictogram or an image of what the current status is, you can use that internal API for that. When the entire flow is completed, you will get an access token. And also this can be a bearer token, but it can also be a depot token, just as earlier. This is, if I'm not mistaken, yeah, all the interaction your client application will have to do with the nuts node. For the user, a lot of stuff will happen. But the current implementation and also the wallet being a cloud wallet where there's not a lot of user interaction required, the user will actually be redirected first to the nuts node, then to the verifier, then back to the nuts node, then another internal call will be done from the nuts node to the verifier, and if everything is correct, then the user will be redirected to the verifier, back to the nuts node, and then back to your callback location. So if all is well, the user won't notice. And in the future, somewhere along these steps, we can also introduce a UI, for example, for a choice. For example, the user wallet stored in a nuts node doesn't have the credentials required from the verifier. Now we can make a choice, for example, like rendering a QR code. Maybe that user has a mobile wallet and can add an additional presentation required by the verifier. So there's a lot of flexibility in it. This information from the user we pass, we actually use it to create a user in-memory user wallet. Okay. In the end, the user will be redirected back to the redirect URI you gave via the API. You use the session ID to get the access token. In case of an error, you will get an error and error description as query parameters to your original redirect URI. And you can use that to render a nice error page for your user, or it can be very generic that says, so something went wrong, please try again later. Or one of my favorites, something went wrong. We notified our developers. They will fix it for you as soon as possible, with all kinds of red lines and stuff. Or we can do the Microsoft way. We can say, okay, error 10,356. Please follow our knowledge base to see what went wrong. Anyway, so you will be getting this error back. You have to do something with it. You can redirect the entire page, use iframes, pop-ups, whatever you want. And you can also use the depop variant in this for additional security. Also in the future, we'll be closely looking at what the OpenID for VP specification version will be. And hopefully we can get some demos running where we can use different publicly available wallets to do some kind of hybrid flow, like use the organization wallet from the nuts node, but also use a mobile wallet from one of the other worldwide vendors, for example, the Microsoft wallet. Okay, I think this is the final part, access token introspection. So now the access token has been sent to the resource server. You can do access token introspection on the introspection endpoint. The access token is passed with form URL encoded as according to the spec. Currently, the nuts node just issues ephemeral random access tokens. We store quite a lot of information connected to this access token, which doesn't fit in the JSON Web Token. So these are just 256 random bit access tokens. The return value will give you a lot of information, which I couldn't fit on a single page. So the information below is the default assertions you would expect from an introspection point of view. So you have your actor true or false, you have your issuer, subject, client ID, expiration, issue date, and the original scope that was used to request the token. So these are all very basic information. Next, you will get additional information. So several things. There is the CNF field. I always forget where the letters stand for. Confirmation field. So this is a Depop specific return value. So if you're using Depop, this is the hash value of the used public key stored in the JKT field. So if you're using Depop, you need to pass this field along to a next API call. Then there is something interesting in this bold field. I'll talk about that in a minute. And you will get all the presentation definitions, presentation submissions, and verifiable presentations that were used in the entire OpenID for VP flows, a plural. So the presentation definitions, they should contain, of course, all the presentation definitions that were required for that scope. The submissions tell you about how the verifiable presentations map to the presentation definition. And then, of course, you will have the verifiable presentations as well, which is a pretty big structure with cryptographic signatures on it. So especially during development, if there's a reason that you need to look into the actual verifiable presentations, then that's possible. But hopefully you shouldn't, because this field in bold here, the presentation definition input descriptor column value. So this is a dynamic return field, and you can have a lot of those. The key for this one, which currently says presentation definition input descriptor, is taken from all the input descriptors that are defined in the presentation definitions. So what does that mean? Let me show you. So in your presentation definition, right? So this is your basic, what do we trust? What do we need to be verified with cryptography? You have this big file that says, okay, I want a credential, I want an organization credential, and only, for example, issued, in this case, by vendor A. Right, so if, for example, there will be an UZ credential, you probably say, okay, I want a credential, I want the type to be an UZ credential, I want the issuer to be UZ.nl, I want the UZ number to be non-empty, I want the URA number to be non-empty, and I want the name to be non-empty. This is something you can define. And all of these requirements, you're going to give them an identifier. So in this case, there is a ID nuts care organization credential identifier with a constraint. What the introspection will do is use that identifier and return the value for it that was found in the actual credential. So if you have a big list of requirements for your credentials, in the end, in the token introspection, you will get a very flat structure of all your requirements and the values that are available in those credentials. This will save you a lot of time because you don't have to parse all the verifiable presentations and credentials yourself, because they also have a dynamic structure. It saves you up on a lot of JSON path translating And all of these values can be used in the next step for authorization. So in this case, there's a constraint for a care organization credential, and I want the issuer field to contain one specific value, namely vendora.com. So this is also used in OpenID for VP. This requirement is sent to the wallet. It will be matched against all the credentials in the wallet. And if it can find a credential that satisfies this requirement, it will be used to create a verifiable presentation that will be sent to the verifier. And then in the token introspection, this requirement will also be available as a single value. Now, why is this important? Now we're going to be a bit into the architecture. So if you look at the resource owner side of things, if you look at the requests coming in, it will probably pass through some kind of load balancer, then some kind of TLS termination, and then it will come to your authentication part. So the access token is introspected at the nuts node, and then you will get a lot of values back that you can use in the next step. Right, and the next step, the authorization part, which is a very basic authorization scheme. We call them, we use the XACML definitions like policy enforcement point, policy decision point, and policy information point. So after the authentication part, when you know about all the assertions from the client, you're going to match that against the policy for your use case. And if there's a successful match, your policy enforcement point will have the request go on to your Fire API, for example, or another endpoint, or it will deny access. So that's the only job for the policy enforcement point, is just to say yes or no, and the request can go through or not. The decision on how to do that is made by the policy decision point. And what the policy decision point needs for that decision to make is everything from the access token, so the return values from the entire introspection result, which has all the DIDs in it, it has the scoping, it has the HTTP method, HTTP path, but also all the relevant parts from all the credentials used are given to the presentation decision point. Well, there's different ways to set it up. As a vendor, you can decide to create your own enforcement point and decision point, but we're also going to try to get some open source components available, and maybe even make it so that this policy that you load into your policy decision point can be used by different implementations. So we can provide a generic policy for use case, so you only have to load it and then your authorization part is done. If the information from the token introspection and from the request isn't enough to make a decision, and you need, for example, additional runtime information, for example, a overdraft has an overdraft being made available, yes or no? Is this resource made available, yes or no? That kind of runtime information is taken from the policy information point, which is probably connected to your own database somewhere. Also, for example, I only want care professionals that are involved in the direct care for this patient. So this is a patient, and the network of the patient says this is the GP, this is the pharmacist, and this is my cardiologist or something. So those are the only people that should access the information from this patient. That's runtime information, and that should be available through your information point. And it should be a very simple call, because all the identifying information is already taken from the token introspection. You already know which organization is requesting, for which patient it is, to which organization it is. You know information about the user, so you only have to check, are those involved with each other, yes or no? This is also something will be going to invest a little more into in the coming weeks and months. So we're going to describe more on our wiki page. We're going to put this into practice for our own demos. We still have a demo EHR, so we're going to see how this will work for a overdracht, for a zorginzage, shared care planning, that kind of stuff. To see if this is viable and a good way to make more components reusable. So, just to conclude, all data needed from verifiable credentials must be present as a constraint in presentation definition. So you will get them as a flat structure, as key value pairs. And as I said, we're going to look at this enforcement point, decision point, information point components and see what we can do to make this more easier for reuse. It might be something that you would say, oh, I don't know what this is. This is something new. But this enforcement point, these three-letter thingies, every implementation have them. And I suspect that most of them exist in hard-coded rules in some kind of programming language. I think there are a lot of pieces of software that just do if this, then that, if this, then that. And when these policies become harder, it's very easy to make mistakes. And it's very hard to check for these mistakes if every vendor is using a different implementation. And also, it might be okay if you're supporting just one or two use cases to have this hard-coded, but if you're going to support 10, 20, or 30, it becomes quite a mess in your software. This concludes this session on access tokens.